In this video, I want to introduce you to the number I, which is sometimes called the imaginary unit. And what you're going to see here, and it might be a little bit difficult to fully appreciate right from the get-go, that it's a more bizarre number than some of the other wacky numbers we learn in mathematics, like pi or e. And it's more bizarre because it doesn't have a tangible value in the sense that we're normally used to defining numbers. I is defined as the number whose square is equal to -1. This is the definition. This is the definition of I. And it leads to all sorts of interesting things. Now, some places you will see I defined this way. I as being equal to the principal square root of -1. I want you to just point out to you that this is not wrong, and it might make sense to you. You know, if something squared is -1, then maybe it's the principal square root of -1. And so these seem to be almost the same statement. But I just want to make you a little bit careful. When you do this, some people will even go as far as saying this is wrong, and it actually turns out that they are wrong to say that this is wrong. But when you do this, you have to be a little bit careful about what it means to take a principal square root of a negative number, and it being defined for imaginary, and as we'll learn in the future, complex numbers. But for your understanding right now, you don't have to differentiate them. You don't have to split hairs between any of these definitions. Now, with this definition, let's just think about what the different powers of I are. Because you can imagine, if something squared is -1, if I take it to all sorts of powers, maybe that should give us all sorts of weird things. And what we'll see is that the powers of I are kind of neat, because they kind of cycle, or they do cycle, through a set of values. So I could start with, let's start with I to the 0th power. And so you might say, hey, look, anything to the 0th power is 1. So I to the 0th power is 1, and that is true. And you could actually derive that even from this definition. But this is pretty straightforward. Anything to the 0th power, including I, is 1. Then you say, okay, what is I to the 1st power? Well, anything to the 1st power is just that number times itself once. So that's just going to be I, really by the definition of what it means to take an exponent. So that completely makes sense. And then you have I to the 2nd power. I to the 2nd power, well, by definition, I to the 2nd power is equal to -1. Let's try I to the 3rd power. I'll do this in a color I haven't used. I to the 3rd power. I to the 3rd power. Well, that's going to be I to the 2nd power times I. And we know that I to the 2nd power is -1. So it's -1 times I. Let me make it clear. This is the same thing as this, which is the same thing as that. I squared is -1. So when you multiply it out, -1 times I, we'll write as -I. Now what happens if we take I to the 4th power? I'll do it up here. I to the 4th power. Well, once again, this is going to be I times I to the 3rd power. So that's I times I to the 3rd power. I times I to the 3rd power. But what was I to the 3rd power? I to the 3rd power was -I. This over here is -I. And so I times I would give you -1. But you have a negative out here. So it's I times I is -1. And then you have a negative. That gives you +1. That gives you positive. Let me write it down. So this is the same thing as, so this is I times -I, which is the same thing as -1 times, remember, multiplication is commutative. If we're just multiplying a bunch of numbers, we can switch the order. This is the same thing as -1 times I times I. I times I, by definition, is -1. -1 times -1 is equal to 1. So I to the 4th is the same thing as I to the 0th power. Now let's try I to the 5th power. I to the 5th power. Well, that's just going to be I to the 4th times I. And we know what I to the 4th is. It is 1. So it's 1 times I, or it is just I again. And so once again, it is exactly the same thing as I to the 1st power. Let's try, and just to see the pattern keep going, let's try I to the 7th power. Sorry, I to the 6th power. I to the 6th power. Well, that's I times I to the 5th power. That's I times I to the 5th. I to the 5th, we already established, is just I. So it's I times I. It is equal to, by definition, I times I is -1. And then let's finish off. Well, we could keep going on this way. We can keep putting higher and higher powers of I here. And we'll see that it keeps cycling back. And in the next video, I'll teach you how, taking an arbitrarily high power of I, how you can figure out what that's going to be. But let's just verify this cycle keeps going. I to the seventh power is equal to I times I to the sixth power. I to the sixth power is negative 1. I times negative 1 is negative I. And if you take I to the eighth, once again it'll be 1. I to the ninth will be I again, so on and so forth.